Okay, so hello everyone. Thank you for joining us for this webinar. Uh, I am Jefferson, and with me is Carlos. And thank you all for joining us. We are moving on with our series of webinars talking about uh, stress test, application performance, and so on. Today we're going to talk about performance bottlenecks, and we're going to talk about some reasons to worry about performance, and then we're going to talk about how to approach those issues, performance issues, and we're going to see some tooling as well. Okay, so just we are from Actminds, and Actminds is a US-based software company. We develop custom software, and we can also help with designing cloud applications and things like that. Okay, and of course help with the performance of your application. So let's start.
Can I just give you one update on this? Yes? Okay.
Yeah.
We chose this topic as a follow-up on our previous webinar that was a performance evaluation of your application. So what happens during the previous webinar, we went through a couple of tools and other techniques to measure how your application responds from a user perspective, from an end user perspective. And we noticed that we were able to identify situations where the application with a specific amount of users accessing it at the same time would cause a bad experience to the users. So this webinar for today is a follow-up on the previous one and trying to analyze our application on the back end, our servers, our code, our infrastructure to make sure so we can identify which are the things that bring more value from a performance perspective that we should address on your application, right?
Yeah, thanks for that.
Okay.
So the first question is, did your load tests show you any performance issues, right? Because, yeah, stress testing your application is one way for you to learn that your application has scalability and performance issues, of course. And as Carlos mentioned, that was shown in the previous webinar. But other ways for we to learn that sometimes there's a bad way that from our users, okay? So sometimes our users are having a bad experience because of the performance of our application. Sometimes the application can handle a number of users, but after that, the performance drops a lot. And if a user is having a bad experience with your application, then that may cause the user to leave you. If the user is having a bad experience with one of your applications, maybe because of that, he can leave all of your applications, your whole set of applications. And that's, of course, a bad thing because you're losing money there. And sometimes you have internal systems, and those internal systems are not performing well as well. And then maybe your users cannot close deals because of that performance. And then there's money lost as well. So yeah, performance matters a lot. So there's this question. Have you run your load tests? Did you see any performance issues? Did you see something that you should worry about? Okay. Another time when we may feel the need to work on performance is when we are developing. Yeah, we do not want to think of performance for every piece of code we create, but sometimes that specific part of the code feels slow. You feel that it's not performing well. So what do you do then? Yeah, how do you work on that situation so that first you find out if it's performing well or not, if there's any suspicious behavior in terms of memory or processing or something like that. How do you measure things? So when you're developing, yeah, sometimes you feel the need to work. But of course, to figure that your application has performance concerns when you're developing or when you're testing it, it's much better than learn from your user. Another way you could learn that is by your continuous integration cycles. Of course, whenever you integrate, you're going to run tests. And if you see a performance drop in that, then run that again and again. And if performance is still low, then you know something went in and that's causing performance problems. Okay. Hey, Carlos, please feel free to chime in whenever you want. Okay. Uh, so after you figured out that you have a performance problem, so the next question is, where is it? And where should I put my optimization money, my efforts?
Hey,
Okay.
Jefferson.
Hey, yeah, go ahead.
Maybe the next question would be to our attendees.
Oh, yeah, nice
Have
one.
they seen any performance issues lately?
Oh, yeah, yeah.
I am going to share with you a little poll so you guys can vote on the answers that make more sense to your reality so we can understand a little bit better how to direct this. Okay, almost done. There are still people voting, but um, the, the, the winner here is the last option that says, that's why I'm here. So I bet most people are having issues with their production environment regarding performance, right? Good to know because we
Yeah,
can help you. It's not good because of the performance issues in your production environment, but good to know that you're here.
yeah, yeah, for sure.
Okay, let's
Yeah,
move forward then.
yeah, you can close the ball. Yeah, thanks for that. Uh, so we know, and most of you guys likely know that we might have performance issues, right? That's what the survey said. Then we need to figure out where should we work, okay? Where should we try to make optimizations? Where are the better gains, right? So we have to derive a approach to figure that out, to find where we should act and what are the issues that we are facing, okay? So we're going to talk about such an approach today. We're going to give some ask some questions that are going to give us some clues to start thinking about the issue, and maybe we start to see some patterns that will enable us to get to the root cause and to fix that. Okay, so that's what we're going to talk about now. Some of the common performance issues we might find are resource locking. Okay, sometimes we try to create threads to parallelize things to use our CPU, but then if we do not synchronize that correctly, we will start to get all those threads serialized, and then we have performance issues. Another
I guess,
issue that, yeah,
I'm sorry.
go ahead, please. Yeah, go ahead. Yeah,
But
no
I
worries.
think this is one of the most important things because there's a lot of buzz out there talking about, wow, you should use a parallel computing, you should use threads, and you should do all this stuff to make things happen faster at the same time. And not that much people understand a little bit the concept of the resource locking, and they run into race conditions. And it's not just because now we're talking about parallelization, but we've seen this for years when you're working with database, right? So you try to update while some other users are also reading data from the same table or same page. This is one of the biggest concerns, that it's not a thing that's easy to identify, easy to reproduce, but it can happen frequently um, if we don't take care while we're developing our code.
Yeah, we should design well for that. Uh, Another thing that we might find is memory leak. Okay, when our application is leaking its memory when we just see memory usage increasing and increasing and increasing. And sometimes you might even get a little lower, but then over time it's increasing, increasing, and it never gets to that baseline memory usage again. So then you know there's memory leak. And one thing about that is that it might be happening been happening for in our application for years, and you might never know that. So yeah, that can cause a lot of performance issues because most of the performance issues are usually related to memory usage. Several of the issues are related to that. So yeah, memory leaks are a big issue. Okay.
Yeah, and when you mention that it could be happening and you don't even know this is happening, because today computers are very powerful, right? They have great CPUs, they have like lots and lots of memory available for processes. So you don't see things breaking because of this leak anymore, but unless it's a huge application with a super load and everything, but it can cause your application to run out of memory pretty quick and start using swap when disk, and that's one of the situations that will cause your application to run slower, but not completely explode just because you're having memory leaks.
Yeah, yeah. And your unit tests are all green, and yeah, you
Right.
still have the issue. And another one is excessive logging. And I think Carlos had an experience with that. He might want to share, right?
Yeah. Well, there was one of the applications we were working with, and we obviously had logging to make sure we can follow up in the process when it's executing and be notified when something goes wrong, right? We're just doing nothing fancy, just the regular logging frameworks out there. And for a mistake of configuration setup, uh, the configuration went to production with a debugging level enabled on our logging uh, setup, which caused the application not to fail, but still was very sluggish. And we kind of didn't realize that this was going on until the day we found the configuration and switched it off. And it felt like you're walking on the street and then you're riding a Mustang, right? You know, it's super fast. It's completely different. Then we realized, whoa, how much time we wasted working in this, and we didn't even realize that it could be much, much faster just because of this setting that's hidden and we didn't pay attention before deploying it. So it's, yeah, it's a
Yeah,
good story.
yeah, nice one. Uh, thanks for sharing. Uh, so we might also find excessive database calls as a reason for performance issues. And sometimes that might happen when you are using ORM tools like any framework and Hibernate or another mapping tool, because there's a N+1 problem. It's a classic problem for database mappings, right? And sometimes that is causing a lot of performance damage. One other thing is that we might have a too low or too high CPU usage. Yeah, and maybe you might find too low CPU usage kind of strange. But yeah, sometimes you have a piece of your application that could make use of more of the available CPU power, and you might try to parallel things, but yeah, take care with lock-in. But yeah, you might try that. And that would make a huge performance improvement if well designed, and your CPU that it's available, it's for you to use. Okay. And another one is the use of exceptions to drive business logic. So maybe your application is raising and handling a lot of exceptions, right? And you might never know because that's happening inside your application and it never explodes your process, right? So that might damage your performance as well. Okay. Of course, this list could include several other issues, but these are some of we found to be the most common and important ones. So we included that, okay? And that drives us to another question for you, right?
Mm-hmm. Let's So we would like to know which are the biggest performance issues that you feel in your application right now, since everybody has experienced this. So what what have you seen, or if you already found where the issue was and was able to fix it, what was it? Was it memory leaks? Was like lagging response time on your application, excessive database round trips, or just general I/O, excessive I/O that will cause your application to read too much from disk and write to network or depend on other services, remote services, that causes your application to be slow? Mm-hmm. All right. Almost got everyone. But yeah, either way, just 67% of our attendees just said that excessive database round trips are the biggest issue.
Nice. Yeah. And I think we can help with that as well. And we're going to learn something nice about it today, right?
Right, right. That's why I'm excited because because I prepared an example to run,
Yeah,
and
yeah,
it's pretty much related with database access. So let's
yeah,
go.
yeah. So thank you guys once again. Uh, so what we have in this slide and in the next are kind of some general questions we can ask to try to think about the issues we're facing, right? So yeah, there is you facing your application and seeing the performance issues. So how do you start? What kind of questions can you ask that can make you start thinking about that and get to the point where you should optimize your application? Of course, this list uh, also does not include all of the questions you could ask, but that serves well the purpose of starting us on the way. Okay, so we might start thinking about memory. What's the memory usage pattern we're seeing? Is it too high? Do we have spikes? Do we have peaks in memory usage? Right? Uh, what about CPU usage? Is my CPU uh, with too much load? Am I using too much of CPU when I'm running determined scenarios, business scenarios of my application? What about integration? Am I integrating with maybe something running in a cloud or maybe even in another cloud or a third-party service? Or maybe I'm just using file system and that might be causing issues as well. Then we should ask, which part of the code is my application spending more time? That would be a good thing. Sometimes we think, yeah, that scenario is the one that's really having issues. But usually a scenario is a huge part, a huge portion of the application. So we should try to narrow it down so that we could find which objects, which methods, which specific parts are in the hotbed for our application. Okay. What else can we ask? Uh, then we need to think about that piece of code, right? Is it taking too long to run, really? Or maybe that's not the case, and maybe I should try to look for performance issues somewhere else. And
Right.
if, yeah, and
No, I just agree with you. And it's
okay,
complicated, this kind of decision, because if you don't know exactly what part of your code and of your application, if it's infrastructure, if it's actually code, and where in code you should put more of your effort to fix this performance issue, it's complicated to just guess. And maybe, and several times when we didn't know about this, I can tell that I personally spent more time working on things like, well, I guess this is the problem because it doesn't, the architecture, the design is not as cool as I thought it would be, and we could save time using this factor instead of creating things by hand. And obviously all those improvements bring benefits, but maybe those are not the actual issues of your application. It will bring benefits, but if you look at the other part of your application where you're, I'm not going to give you a spoiler right now, but if you could just have a cache in memory for data that doesn't change that much, that may save you a couple of round trips to the database, right? And all these little decisions are pay off a lot more frequently than re-architecture and redesign your application to something more organized, or I don't know.
Yeah.
That's it.
So, yeah, you need to think well about where you should invest your optimization efforts and your money, of course, because that means money. So, whenever you found that portion of the application that needs optimization, then you need to think what's happening there. So then you're back to those questions, right? What about memory? What about CPU? What about I/O? Is there any suspicious behavior? What about my memory? Maybe my memory usage is okay, but I might see that my garbage collector is working too much, and that might lead to some issues, okay? So those are some of the questions that we can ask when we are working in performance issues, right? And now that we have the questions, we are gonna take a look at how we can get answers for those questions. So let me bring Visual Studio here to my screen, and I hope you guys can see it well. Let me just open a new window that we're gonna need Sun here. Okay, and then let me just show you what we have here. This is a pretty simple application, right? This just it's just a console application. We have some pretty simple examples, sample code here. This application asks the user to choose one of the samples to run, right? And one example that we're going to run here is just this piece of code here, okay? It's a pretty simple piece of code. It just loops through this for loop here 10,000 times, and it's going to concatenate this string sample to this existing string, okay? Pretty simple thing, and we're not even using that. We're just creating those objects, okay? So let's start, and I'm gonna put a breakpoint in here, and let's start. Let's see how that goes. Okay, it's building, and looks my machine is gonna
slow down a little bit.
Yeah, don't let me down, please. Yeah, yeah. Maybe you might have some performance issues here. Okay, so it's opening. Looks like your guys are seeing a black screen, right? And there should be some text in here soon. Okay, pretty simple. It just asks us to choose something, and I'm gonna choose S for the string memory sample. Okay, and we do not want to see this for now. Okay, so I have a breakpoint in here, right? And I have chosen my test, and I'm gonna run it. I'll just press F10 and see that running. One nice thing I can see here is perftips, okay? And this is a nice tool that helps us to answer the question, how long did this piece of code take to run? And we can see here, it took 500 milliseconds. So we know exactly how long it took. We didn't have to create a batch or a bash script or something to run our application. We didn't have to use our stopwatch or something like that. We just need to break to put a breakpoint on our code, and then we step over that, and then we can see that. One nice thing about perftips is that it always shows you guys how long the application took from the starting point to the current breakpoint, or from the previous break to the current one. Right now, since our application is kind of waiting, right? It's going to ask us to choose another test. And now this application is running, right? So if I choose a test, then it's going to tell me how long it took between the time I pressed the 5, I've typed the letter for my sample, and then it got to the next line. So every time it's going to show you how long it took to run the piece of code. Okay, so I've chosen another test and I ran it, and then I see how long it took. Nice tool, and that's available for you.
Yeah.
That answer
One of
for
the
custom.
things
Yeah.
about the measurements you just got, Visual Studio will automatically tell you how long it took since the last break until the next break. So you're on a breakpoint and you hit F10, you navigate to the next statement. So the tip will tell you how long it took for the previous line of execution. How long did it take for this line to be executed? So you could have those two. Can you see there are two breakpoints there? If we had, instead of hit F10, we selected F5, and we chose the next option that will by chance get into the second breakpoint, Visual Studio will tell us how long it took, yes, to go from one breakpoint to the other. Doesn't matter if it was just processing, doesn't matter if it was waiting for the user input, it will just wait and continue executing the application and measuring time until you reach the next breakpoint.
Yeah, and if maybe you can see that we have this breakpoint here, and if I just press Control F10 or right click here and say run to cursor, where is it? Run to cursor. Here, yeah, I couldn't find it. I just click that, and then it's going to show how long it took from that point to this break. Okay, so every time it breaks, you can see how long it took. Okay, so that answers one of our questions, but we have some more questions to answer. Okay, so another one which we're going to use the string example once again to test. Okay, so let's run that. But before we run that, I want to show you guys this nice little tool. This is Diagnostic Tools window. And this tool shows us events which are being collected, the calls being made, what is the memory usage for our application. So you can see here, right, exactly what's happening in the call stack. You can see who is using more CPU. So there's a lot going on in here, and that's always available for you. So you can even take snapshots of your memory usage, right? So you can take several snapshots
You can
whenever you're
compare it.
running. Yeah, you can maybe start running. So let me press F10, and okay, it's not running yet. Okay, take a snapshot. And okay, it ran, it's showing me the time it took, it's showing me what's happening there, so I can maybe zoom in here in the timeline and take a look at that. Okay, so yeah, there's a lot going on. You guys can see here. So we're going to talk about that. And maybe you can open this memory analyzer and you can compare things, right? So you can see how the memory usage increased and things like that. And so this is pretty nice. You can use a lot of this when you're debugging your applications, when you're working on performance issues, okay? talking a little bit more about this part of the diagnostic tools, one nice thing we can see is that our application didn't use a lot of memory. If we get back to our memory sample here, we are creating this, we are running through this 10,000 times. Every time it loops through it, we're creating a new string. But yeah, garbage collector is taking some time and the memory isn't getting lower, right? That might tell us something. So let me, you can see here also that we have a small peak in CPU usage, right? And then it starts dropping and things kind of stop at this point in here, okay? So yeah, that is a nice portrait of our pretty simple, pretty small code,
Yeah,
right?
are
Yeah.
very innocent and naive to do the string concatenation.
Yeah, you want to talk about that?
Yeah, well, uh, it's pretty trivial concatenating strings, right? But once we do that inside a loop, that's where things start to get a little worried. And this is, can you see on the chart, on the process memory chart, and we see all those garbage collector interactions on the top. So what does that mean? What's so wrong with concatenating strings? Well, in C Sharp, I bet in Java and other languages, most languages, strings are immutable objects. So you cannot change. You cannot change the text inside of it. When you do a concatenation, what happens is you create a new instance of a string with the value of the other two strings you're concatenating. So what this does is it will move the pointer in memory to that string variable will have a pointer in memory to a new location. And what happens to the other two strings that you just concatenated? They're not going to be used anymore. So it goes for, it's made available for garbage collection. And you see that in this example that we just looped through 10,000 times to add this. I don't think it matters what's the size of the string. Obviously, for garbage collection, if you're thinking about memory, it will hurt more if it's a bigger string. But look at how many times, how many objects we just disposed. We just started to not reference anymore, how much trouble we're giving to garbage collector. And this processing power could be used for things more important on your application, right?
Yeah, yeah. Although these collections can happen in a background thread, yeah, that's still hurting our process, and that is a big issue. And one might think that, yeah, this is basically this is trivial when we do not concatenate strings. We do not create sample applications in my company. But sometimes we are creating XML files, we're creating JSON outputs, we are in legacy applications maybe creating HTML to return to our front end, and that may be strings concatenation. And yeah, that's not sample, that might be production code concatenating strings, and that's something to worry about, right? So is there a better way to do that? Let's take a look at this other example. Let us run this string builder thing. Okay, so let us see. I'm going to reset my view here, and I'm just going to run this. So let me remove. I'm not interested in perftips right now. I just want to see what happens when we run that. Okay, so if we take a look here, it looks like garbage collector also worked a little, right? We had a similar CPU usage, and it took some time. So how is this example better than the other one? Let us see what's happening here. Instead of concatenating strings, we are using a string builder, and this is a specific object that is aimed at creating big strings. So how does that work? you create one string builder. Yeah, it's a more expensive object than a string, but it's just organizing data, and it's not creating new instances of that string every time you append a new string to it. It's just going to create that string for you when you call its toString method at this line. But please notice that we are looping through this 1,000,000 times, and the string example was just 10,000 times. Can you imagine how bigger this string is and how much more processing we would need if you were doing that with a string concatenation? So yeah, that's a much better way of doing this. And I know most of people use this, but sometimes we can forget about that and just concatenate strings in our code, and that might not be a good idea. Okay. So yeah, here we can see that we found some suspicious behavior in memory usage, garbage collector working too much. We can map how is my CPU, my memory. We can see our call stack, right? There's a lot we can see in this diagnostic tool. But there's another tool that I'd like to show you guys. So let's stop this for a moment. And let me remove this interaction part of this application. Okay, so, okay, this is what we would like to see. And I don't care for this breakpoint. Yeah, this is not gonna even stop here. I'd like to show you guys another tool. This is the performance profiler, right? And this is a nice one as well. Although it's kind of a legacy tool, it still has a lot of value. We choose it here in debug, performance profiler, or we can Alt F2, and then we can start. The target for our analysis here is our startup project, which is our single application in the solution, single project here, our console app. And we are just gonna run it. Let me just do, yeah, we're gonna run it for that. Oh man, I didn't change that for choice. Ah, what a shame in here. But yeah, let's move on. Okay, so let us run that string example here as well, once again. And then we are going to see what value we can get from this application, from this profiler. Here we have some options. We want to take a look at some measurements of the processing of our application and where is our application spending more time. We might have options for checking for locks, deadlocks, or memory allocation, but now we are interested in CPU and processing, okay? We have two options for that, CPU sampling and instrumentation. CPU sampling is kind of, from time to time, the profiler is going to take a snapshot of our call stack, right? And in the end, it's going to tell, hey, from 100% times, I took a picture of your call stack. This function was present, okay? This is the function which was being run at that exact moment. Or maybe it might say, hey, 30% of the time, this function was not being run, but it was present in the call stack. And all of those things could give us clues to what's happening inside our application. But if you do not care about dropping the performance a little while running the profiling, we could use instrumentation. And this is going to offer us a lot more options because it's going to collect much more information from our application running. Okay, because it's going to collect all of the function calls and it's going to count every single call that we run.
Yeah.
And this is,
well, the biggest difference is when you're sampling, you're collecting information from time to time and then you analyze it. And when you're instrumentating your code, you're analyzing every single call. So expect your application to run slower in that scenario, but at least the purpose of your monitoring might be different, right?
Yeah, exactly. Those might be different moments, right? Okay, we just select our application, and we're going to start. We're going to run the performance profiler, and it's going to run our application that string example here, and it's going to stop, and it was pretty quick, but that serves the purpose here. Of course, you might be thinking that you do not have those kind of sample applications on your company, and I totally agree with you. So instead of simply running this simple console, imagine you have a website, and that website has some scenarios that are taking a lot of time to run. What you might do is start that application, and that works for your web applications, and start that with performance profiling, and go through all of those slow, bad performing scenarios. Allow for a profiler to collect all of that information, and then you stop your application, and it's going to generate a report for you. And you can see that this report has a lot of details, right? And that might serve you a lot. First thing, it's going to show you the CPU usage over a timeline. But the big thing I'd like to show you guys here is this hot death thing, okay? So imagine that instead of running this string concatenation example, you run your application, your website, and then you're going to see the hot death. And this is where your application is spending most of its time. And then you know where to invest your time, where to invest your money to optimize. We can see here that string.concat is doing most of the work. Yeah, but string.concat is not our code. So the next level is our code. So we know now, of course, that string concatenation happening inside this part of the code is to blame for our bad performance. It's the part of the application that is taking most of the time. You might have similar results with your website or any other thing you're running just by running this profiler. Okay.
Yeah, and the cool thing is this tells you exactly how to save 90% of your application performance just changing that piece of code.
Yeah.
It's not, there are things, there are times that there's nothing you can do. It is what it is, but most of the time there are improvements you can make with, let's say, caching or changing the concatenation by using string builders and all this kind of techniques. So it's worth to at least know where the issues are, and then you can think about how to improve that instead of just wasting your time fixing or trying to guess what's going wrong. Because you know the user behavior, and I know when the user clicks that button is going to access this table, so let's go to the database and add another index. So maybe this might be easier to get more performance when you get the results back from the database and just concatenate all the names for generating logging messages, which is a pretty common scenario that I've seen before too.
Yep. So let me close things and get some restate here. This is another example, okay? This one we are going to use a pretty simple web API. It was crafted by someone, a colleague here, which I'm thankful to. And it's a pretty simple thing. The only thing here is, okay, let me remove this. This is not for now. Okay, let me do that differently. Okay, let me just duplicate this. I know you guys are kind of, oh, why that? But yeah, just to avoid surprising demos. You know, demos used to give us some surprise. And then let us remove this for now. what are we going to talk about here? So just pretty simple web API, just have some operations which are going to return as some pretty simple JSON objects, right? It's going to query a database and it's going to bring us back some data. I'm going to show you guys this thing happening. It's using NIDA framework, okay, and it's a database first implementation, pretty simple, basic. So whenever we run it, that's how it works. Go to the database, get the data we are asking for, and then return that to us, okay? So let us close diagnostic tools for now, and let's see that running. I have some cheat sheet here to copy some URLs because I don't want to have to type them by myself. Okay, so let us run that through command line. Yeah, it looks like my keyboard is not misbehaving today. Okay,
It
so
should, because we're recording, right? This always happens when we're recording.
yeah. I'm wondering what's gonna happen next, you know, because yeah. So after a moment or two, because we're kind of just in time compiling this, and it's the first time we're executing, and maybe because it's a demo and that might fail as well, we're getting just one employee, or maybe we're not getting anything from our API. Okay, maybe this employee doesn't exist, but we're just passing an ID for it, and you expect to get some result from the application. Okay, so yeah, it returned, and as you guys can see here, the response says, yeah, there's nothing with that ID. We have some other methods here, like we can get a list by name. Okay, we might. Oops, it's not gonna work this way. Okay, yeah, bad keyboard, bad boy. Okay, so you guys can see it's just JSON objects being returned. Okay. One thing that might happen when we are using ORM tools like Entity Framework or any other ones is that we might get some excessive database calls without even knowing that. So let me do something. Okay, let me show you guys something nice here that is inteltrace. Let me open inteltrace. Okay, inteltrace is enabled, you guys can see here, and it is collecting information, right? So if I see my diagnostic tools, I can see here what's happening with inteltrace. You guys can see that this API has also application insights enabled. Application insights is going to collect telemetry information from our application. It can also help us to find exceptions happening inside it. It can help us with performance issues as well. But yeah, that's not in the scope of this presentation, but that's a nice thing to know. You're going to send this to the cloud and you can do a lot of measurements and you can have analytics over it, and a lot of good things can happen based on application insights. But another thing I want to show you guys is that select statement. We called two methods from our API, and you guys can see we have two select statements here, right? So let us call another method, and this one is going to get not only the employee, but its address as well. So that is a pretty simple example as well. But we started to see a lot of select statements around here. and I don't think they were invited to this party. We just called one more method. We should only see one more select statement, right? And we can filter what we want to see here because sometimes there's a lot of noise on this window, so you can filter things, right? And you can also filter by typing something here. One nice thing about this is that it not only collects this information, but it also shows us if we're accessing some files, if any hidden exception is happening inside our application, and a lot of good stuff. Okay, so looks like it's taken some time to return our objects. There's something wrong happening. Why all of those objects? One nice thing about inteltrace is that it has this historical debugging feature. So let me activate that, okay? And something nice happened here. Historical debugging allows us to take a look at our code like as if it was happening right now. So yeah, I think I'm looking at the wrong select statement in here. So let me choose a new one and let me activate historical debugging for that. Okay, so let me continue here. Application is in break. Okay, and then I knew that, right? Okay. It didn't finish yet. Okay. It does not want to show me that. Let us wait just a little and let us break this and let's see if that works. That behaves better now.
And the thing here is, I'm just going to
Yeah.
while you find out.
Oh, it returned. Yeah, yeah. Go ahead.
Wow.
Go ahead. Yeah, go ahead.
Yeah, I was going to say that although all this RAM save us a lot of time, there's a lot of configuration that we need to pay attention to, and there are lots of different kinds or modes of how to fetch data from database. And in this simple scenario, we always want to use lazy loading, right? Don't bring excessive things from the database so we can make the interaction between the application and database as quick as possible. But in this case, there's a loop in there, and we're going through all the employees and then fetching all the different addresses for each of those person objects. So this is a big hit when you get a list like this that has, I don't know how many, but you obviously see that when you're lazy loading, you're going to look for the objects that relate to the object you're working with as needed, not from one single call. So this is cool because your application was still working, it will still get test passing, it's all green. QA is not going to even notice what's going on because it just runs for a user, maybe a couple of QAs running your application in QA environment. But when you put it out there in production and you suddenly have hundreds or thousands of users accessing your application at the same time, this is when things are going to start slowing down and you don't have a clue what's going on. So this tool will tell you, wow, there must be something wrong with this because I'm just fetching employee contacts, and look how many SQL statements or how many queries are going back and forth in the database to just populate data for this list. Right, Jefferson?
Yeah. So thanks for saving my skin there. Yeah, they almost fail. But so we're talking about historical debugging, right? So we we double click it or we click it activate historical debug in here, and it shows us that this SQL statement is being issued when we call this person address property on that person object. As Carlos was mentioned, we usually might have this issue when we're using lazy loading on our database mapping, right? We're saying to the mapping tool, hey, just bring me what I want to. And then just when needed, just in time, you're going to get the other values because I might not ever need this person address, okay? So then we're looping through maybe 1,000 or 2,000 people, person objects here, and we are calling the person address property for that, and that is creating a SQL statement to our database. So that's not a good thing, right? But talking about inteltrace once more, here in the historical debugging, you can see that everything here says historical debugging. And that's a nice thing. You're not live. We are debugging something which happened before, but inteltrace kept all of the information. So we have the context to do another debugging session on something which happened maybe 1 week before. Okay, so that's a pretty nice thing because we can even do something nice here, which is to save this output when we enable inteltrace. We can save this, okay? So we can get those files and share with another developers. A QA person could run a scenario with inteltrace enabled if he finds a issue, and then he could start a file, open a defect in the tool of choice, and attach that inteltrace file to that defect. And the developer working on that could get that file and execute the same session that our QA folk was happening to execute. So that's a pretty powerful thing. And then back to what we have here. We have all of the variables. We have everything, right? So that we could execute that as if you are debugging that session, right? But what about our n+1 issue? How do we fix that? Well, the way to fix that is to tell our ORM2 not to lazy load this property, right? And that is what we had in here at the time, right? So let me uncomment this one, remove that one, and then I'm just gonna reformat that. And so here what we're doing is, please, any framework, get us people, but at this time, please also bring the address, okay? So we're not doing that for every single method because we might have some case in which you just wanted the people, and we do not care if we're going to the database 1 or 2 more times. That's a trade-off. We might not want to bring a whole lot of data from the database disk to memory just to use 1 or 2. So sometimes lazy loading is the way to go. But in this case, we're wanting a whole list of people with addresses. So we do not want lazy load. So we're saying, please, bring that as well. And if we run that again, okay, so we're going to see a new inteltrace session. Let me just check. Okay. So here we can see CPU, memory, and everything. Let us run the code again. And let us filter those events so that we can see how many select statements we are sending to the database when we run that. Okay. Yeah, we need to wait just a little more, allowing for that to execute, because yeah, that's bringing a lot of data here. You can see that memory usage is increasing, right? And it didn't return yet, but we can see that if we remove the filter here, we're seeing that a lot of things happened. We can even see that there are some issues happening here that might be another lead that lead us to another performance issue, right? But you can see that just one select statement was sent, and Framework is optimizing it its own way, right? Doing a subquery here. That's its way of doing that. But yeah, we're just going to the database once, and we're bringing everything at the same time. Okay, and that's how inteltrace helped us to find that. When you're using inteltrace, you can even choose which events you might want to look at. Okay, let's leave that running for now. And okay, it ran, and it already returned, and just one select statement was sent. So we know we fixed that with help of inteltrace. But back to the settings. Here we can filter which specific events we are interested in. So if we do not want to see ASP.NET events, we might remove those. If we want to see threading events, we can check those. If we want to see file access, we can enable those, right? And if we have third-party assemblies, third-party modules, libraries we're using, we might not be interested in collecting events from those. Then we can add those modules to this part of the settings so that we only collect events from the code we created, right? Because that's reducing the load, the amount of events we are collecting. Okay, that was a lot of information. I think we can stop this guy. We can remove this window and this one, and I think we got answers for these questions as well. We've figured out how to find if there are hidden exceptions being raised and handled inside our application. We found out that we had excessive database calls on our application, and we saw that using inteltrace, you can enable file events and see if maybe there is something you are accessing too much, or maybe there is something happening. We have a permission issue or anything like that also happening on our application. We have covered a lot of ground today. We have talked about common performance issues, and before that also, we talked about the value of performance for our users and how we might lose money by having a bad performing application. Then we talked about some of the common issues we might find in our application, and the common ones like locking, excessive database calls, excessive login, memory leaks, and things like that. We talked about some questions that one can ask to start thinking about how to face that situation, how to fix that. And then we had some demos showing some tooling we can use with Visual Studio to work on that. But next thing I'd like to talk to you guys is that we should not optimize without a real need. Donald Knuth said in his paper, Structured Programming Go-To Statement, that there is a premature optimization is the root of all evil. And the thing is that if we try to optimize everything, we might spend a lot of time, a lot of effort optimizing things that are not going to bring any value at all when you think of the big context of things, right? Maybe you make that piece of code so complex and so much faster, but that's add just so little to the performance. But when you have a complete business scenario, when you have something big that you can test, yeah, then that's a good time for you to worry about that performance.
Yeah, that's a good point because you might be, oh, I know there's performance issues in this piece of code, but only 10% of my users get to that page, I don't know, once a month when they need to run some specific report or whatever. So is that important, or should you focus on getting more performance in other areas where 90% of your users are going to, right?
Yeah, exactly. So, of course, when you're developing, sometimes you know that that piece of code should be much faster, as we saw in the example of concatenating strings, right? But sometimes we as developer need to be careful not to try to optimize everything and spend a lot of money in something that's not going to bring a lot of value. So is it time to look at performance? Have you run your load tests? Did they show you that there is a concern? What about your automated metrics, right? You're continuous integrating and then you're seeing performance slowing. Yeah, then you should work on that. And every time you are concerned about performance, do not trust one run only. Run it several times. Do your test more than once so that you can compare the results and then you have a solid base to analyze and then you can confidently say that you need to work on the performance issues of your application. Yeah? Carlos, do you have any comments?
No, I think we covered it all. And uh, I know it's a lot to absorb from what we just did, so I would like to, can you go back to the first slide where we have our emails, please?
Oh, yeah, we have them here as well.
Okay,
Yep.
so thank you guys for watching, and if I know there's a lot of things that we talked about, too many things, so in case you still have any issues, any questions, or I don't know, just feel like chatting with us, feel free to reach out to those emails and we'll be more than happy to support you on whatever's needed.
Yeah. We really appreciate you taking your time to join us, or you're watching it later. But yeah, anyway, we really appreciate and feel free to contact us. We are glad to help in any way we can. All right. So thank you guys. Thanks, Carlos, and see you
Just
soon.
one more thing, yeah.
Yeah.
And the URL that you clicked to navigate to this webinar, the same URL still works, and we're going to be downloading and processing the video, and we'll made it available. So if anytime you need to come back and rewatch parts of this video, you can still access through the GoToWebinar page.
Oh yeah, thanks. Nice point. Okay, so I think we're closing now, and we really really thank you for joining us today, and hope this is useful for you guys. And please contact us whenever you'd like to. Okay.
And stay tuned. Soon there are more webinars coming.
Yeah, we're gonna move on with this series of webinars, and there's one scheduled for probably 2 weeks from now. So yeah, thank you. Bye.
Thanks, guys. Bye-bye.